That's all.
Great. Thank you, Willem. Again, folks on the call, if you have questions for William and the other speakers, please put them in the Zoom chat for now, and we'll attempt to answer those at the end of all 4 sessions. So with that, we're now going to go to Denarian from DBBS to tell us about his technology. Over to you, Denarian.
Thank you, Alex. Yeah, so please go to the next presentation. Yeah, thank you again for the opportunity, Alex. My name is Denarian Berrio, and I'm the founder and president of DBBS Technology. This time with you guys to bring you a very interesting and unique retrofit opportunity. The technology is called HVAC zero mixing. And before I get into the project, let me give you a quick rundown on what in a nutshell, what the technology is. So let's start first and looking at the skyline for Calgary and looking at all these different modern buildings. One of the things that first come to your mind is that because they are all packed with high efficiency equipment, state-of-the-art instrumentation, and controls, we tend to believe that the operation is basically high efficient, 90% efficiency consumption when it comes to natural gas and electricity. But in reality, the reality is far from there because usually what is the case for any type of building, the efficiency oscillates between 50 to 69, 70%. And that is due to the fact that there is a phenomenon going on into the hydronic system that we call water mixing. Now, to better understand water mixing, let me move you to the next presentation. So here you have on the left side, you have a typical water mixing system, and on the right side, you have a zero mixing system, which is the one that we gonna implement at the Oscar building. Now, in the left side, what happened is, and let's take for instance the condensing boiler system. Now, it is the case for the building, for the Oscar, we have mid efficiency boiler, and the way the system operates is it reheat water at the boiler plant and is sent over to the building. Now, and the way going to the building, there is a return colder water coming back from the building that encounters that flow coming from the hot flow coming from the boiler. When they clash and mix in the hydronic system, basically the piping network, that water temperature or thermal condition get degraded to the point that it's no longer hot, neither cold. Now, when that water is going back to the boiler, because of the fact that boilers, like every other typical HVAC system or equipment, likes a low water temperature return, the fact that that water is not that cold affect the efficiency of the boiler in this case. Now, because of the tempered water now going to the building, the ancillary equipment have to work harder to actually provide the amount of heat that is required to reheat the building. Now, that's what is happening at the water mixing side. Now, on the zero mixing side, on the other hand, what you see there is cold water coming from the building going into what we call a split buffer, and from there straight down to the boiler, and not clashing not clashing with the hot water coming from the boiler, which goes straight to the building. In this case, we maintain something that is very important in every HVAC piece of equipment, which is the high delta T, the difference between the high temperature and low temperature. And basically, that's what actually determines the efficiency of every HVAC equipment. So now you see the difference. These water mixing systems, conventional systems, operate in a low delta T, no matter what type of system you have, and that's an indication of how efficient or inefficient they are. In a zero mixing environment, equipment will tend to operate at a very high, 4 times, 3.5 times higher delta T than the conventional one. Can you please move down to the next one, Alex? Now, for a technology agnostic persons, it's worthwhile to make this interesting comparison between the circulatory system and a hydronic system in a building. And when you look at the color coding, you see kind of a similarity between them. Now, Let's look, for instance, at a competing athlete with a physical configuration to actually reach high speeds in and let's think for a moment and look at the heart and look at, for example, on one side you have high oxygen, low radical, low CO2 blood, and on the left side you have low oxygen, high radical, high CO2 blood. When these two bloods get mixed because of the rupture in the septum, which, by the way, is a disease that is called tetralogy, no matter how physical your configuration is, to do a high speed lift weight or do any other kind of physical exercise, you're barely going to be able to walk. And that's because of the mixing of these two very different type of blood. The same thing happened in the hydronic system. You have two very different type of flows that get mixed into the system and create a very similar condition. You think that and this is the case for every building, not only in Alberta or in North America, that's everywhere around the world where you use HVAC for operation. You think that because you have a high efficiency equipment, you think that the efficiency is going to stay with the building once the equipment gets connected. No, sorry to bring bad news to you, that efficiency is going to be impacted for water mixing. And your building, instead of running in a similar manner that the athlete on the left side is barely going to be walking. The question is now where your building is in that spectrum. But something that I can guarantee you is that if zero mixing is not in your building already as a retrofit, your building most likely going to be barely walking like German monster. So can you go to the next presentation, Alex? So what we're going to be doing in the Oscar building, which by the way is a multi-unit residential building, 31 apartment units and 4,300 square meter, is we're going to be retrofitting the building with the zero mixing, and we're going to departure for the existing configuration. Can you go next, Alex? Which is basically a mid efficiency condensing boiler, direct fire domestic water tank, and makeup per unit system. Now, the nameplate efficiency nameplate for these boilers is around 80 to 90%. But again, that is lab efficiency, which is very different than what you are actually obtaining when you install these systems and make it interact with the building. Now, based on a energy audit we did at the beginning of the project, we estimated that the actual efficiency in the building is about 50%. Now, that drop in efficiency is creating a greenhouse gas emission of around 400 tons of CO2 per year, equivalent, I mean. Can you go next, Alex? With the zero mixing integration into the system, what we're going to do is replace that boiler operation with a high efficient condensing boiler operation now connected to a zero mixing system that is going to perform actually between efficiencies of 91 to 97. And with that, we want to provide hot water that we're going to feed into the domestic hot water system and the makeup unit system. That alone, we think they're going to be able to provide an efficiency, a consistent average efficiency of 91 through the seasonal periods, and going to create opportunities for greenhouse gas emission reduction of about 40%, bringing the CO2 emission production down to 220 tons per year. Can you go next, Alex, please? So, as already explained, unlike conventional systems that are related on traditional water mixing, the zero mixing system allow the building for opportunities in reducing natural gas and electricity consumption, and therefore improving that greenhouse gas emission situation. Now, this technology, we believe, when implanted, integrated into the building, going to create a good opportunity and give us a successful demonstration and the innovation that can be both replicated and be scalable across the ACE market in Alberta. Now, showcasing this technology and using measurable improvements in energy and efficiency and sustainability, gonna give the opportunity to DBBS and the project to real demonstrate its energy savings and sustainability opportunities in the retrofit market. Now, the question at this point that I want to leave you with is, when you're looking at the building from the owner perspective or the building service company perspective, the question that you have to ask yourself is, where am I? Where is my building in this spectrum? Am I thinking that I'm running, or basically I'm barely walking down the road at a poor mid-size efficiency? And keep this in mind, no matter what type of retrofit you are using to leverage the efficiency of your building, if you're not doing zero mixing retrofit or getting rid of that water mixing operation, you're barely going to achieve, or you're going to achieve a significant efficiency, but you're never going to get to the real potential of the equipment that you're actually installing. With that, Alex, I give you the floor and thank you again. So back to you.